In this video, I will show you how to use a joystick to control servos. And there are two servos in this moving head. And for the first time, I will also use arrays. But first, I need my Arduino. Where's my Arduino? Just hanging around for the next project. Let's remove this. So this joystick consists of two potentiometers. One is here and one is here. One side of each potentiometer needs to be connected to 5 volts and the other side needs to be connected to ground. I will call the first signal X and the second signal Y. It also has an integrated button. You can find joysticks like this inside of your Xbox or PlayStation controllers. Let's connect it to the Arduino. So this one is for 5 volt and 0 volts. This one is for the signals. We also need power for our servos. It's not perfect, but it's a fine temporary solution, I would say. Then we have the two servo signals, and I will connect them to pin 6 and pin 5. And this one is for the LED inside. The LED is not driven directly by the Arduino. There's a transistor inside that turns on the LED. I will connect the LED to pin 11. So this is how everything is connected. Let's start with reading out the potentiometer values. I will initiate a serial connection. And inside of our loop, I get an X value, which is analog read 0. And then a Y value 1. And then I just print it out. X as decimal number. I will also add description. So this is X, this is Y, and the last print statement will be print ln, which creates a new line. And we need a delay. Let's do this every 100 milliseconds. Let's open the serial monitor. We get values of around 500, which is around the middle because it starts from 0 and goes to 1023, which is 10 bits. And now if I move the joystick around, these values change. So now I can try to only change the Y value. This is the Y value, and this is the X value. Perfect. Now here comes your exercise. I would like to use these potentiometers to control the servos. So I would like to have values from 0 to 180, which represent the angle. How can we do that? Well, there is a function that we could use that is called map. It works like this. We want to map our analog read 0 value from the old range, which is 0 to 1023, because right now it starts at 0 and it goes up to 1023. And the new values should be from 0 to 180. Now we'll do the same thing for analog read 1, and then we see what happens. So now they are mapped to represent an angle. We can do one more little thing, and that is we don't really need an integer here. We can use byte to save some memory. Works perfectly. All right, so now let's feed the signal into the servos. sketch, include library, servo. First, I will create two servo objects. Now, if you don't know what an object is, it doesn't really matter at this point. Now, the first object will be called X servo, and then we also need a Y servo. We then need to attach these. So let's attach the X servo to pin 5, and let's attach the Y servo to pin 6. And then we also need to write the value to the servo. So X servo dot write X, Y servo dot write Y. As expected, the thing moved, and now I can control it using my joystick. You will see something. Now, if you look closely, you see that it changes at a rate of 100 milliseconds because we have this delay here. And if we reduce this delay to, let's see, 10 milliseconds, then it gets a lot smoother. Of course, we can also just remove the delay and feed the data as fast as possible to the servo. There is almost just no delay. The next step is reading out the button. And you see, sometimes the Arduino crashes because the voltage breaks down, most likely, because the supply is not really stable at this point, but it will do the job. All right, so next up, let's turn on the LED. I would like to read out the button, and the button is connected to analog pin A2. We can actually use the analog input as digital input. Pin mode A2 input. It would look like this. And then I will add 1 byte, and that is light equals digital read A2. And I would also like to print the light. So right now it's 1. If I press it, it's 0. So it's exactly inverted. Because the button connects A2 to ground, and we have this pull-up resistor so that the default value is 1. So here comes the second exercise. As long as I press this button, the LED should be turned on. The LED is connected to pin 11. So pin mode 11 is an output. And here I will just check if light equals 0, then digital write 11 high, else digital write 11 low. Awesome. So now I can also control the light. If I push the button, the light turns on. Awesome. But now I would like to take it to the next level, and this is also where we need arrays. So I would like to record a movement and then play back this movement. Let me show you what I mean. I have two buttons. When I press the red button, this is my record button. This button will be used to record my movements. And then if I press the green button, it will replay my captured movement. I will connect the red button to pin 9 and the green button to pin 8. I will use the internal pull-ups of the Arduino, so the buttons will connect to ground. Now this is quite a project. If you haven't liked and subscribed already, please do so. It really helps me a lot. But let's continue. So first, let me show you what an array is. An array needs a data type. So for example, I can create a byte array. And then I call it servo values. And then we need square brackets and a size. Let's store 100 bytes inside of servo values. I will access this array from interrupt service routines, and that's why I will also add volatile. Now there's one big limitation, and that is the SRAM of the Arduino Uno R3. The SRAM has a size of 2 kilobytes. And so if I would define an array of 3000 and try to compile it, it already tells me that there is not enough memory. So we need to be careful and make it small. I will use 200. What's an array? An array is not just 1 byte, but in this case 200 bytes. And you can store 1 byte in each cell of this array. Now in order to access this array, we can do something like this. Inside of setup, I could do servo values at index 15 equals 5. So this would write the value 5 into servo values with the index 15. So this 1 byte. And the index starts at 0 and goes up to not 200 but 199, because we have a total of 200 bytes. And the first byte has the index 0 and the last byte has index 199. And you need to be careful, because if you actually write it to index 200, you don't get an error. And Arduino will actually write this value into an address that is outside of the range of this array. And this can lead to unforeseen consequences, because there might be a different variable stored there that you now manipulate. You need to be careful here to not change values outside of this range. And now we'll use this array to store all of the values for my movement, because a movement consists of a lot of different values in the end. But I not only need X, I also need Y. I also need light. Here comes your exercise. Make it happen. There are a lot of different solutions, and I will probably use timer 1, and hopefully it won't interfere with the servos, so we will see that, because there is a limited amount of timers inside of Arduino. Let's include timer 1. Timer 1 needs the following things. We need to initialize timer 1. So timer 1 dot initialize. And here we need to input microseconds. I would like 10 milliseconds, which is 10,000 microseconds. And if we use 10 milliseconds, we can actually capture a time span of 2 seconds, which is not much. Timer 1 dot attach interrupt. Let's call it timer ISR. We need to define this timer ISR. Void timer ISR takes no arguments. And for now, I will try zero print timer. For testing purposes, I will just serial print timer. Let's increase it to 100 milliseconds. And let's add a delay here of 50 milliseconds so that we don't miss the message. There is a lot of stuff going on. Okay, let's add a delay of 500 milliseconds. Yeah, timer, and then okay. That's a problem. Yeah, you can see that timer 1 clearly interferes with servo. So because I use timer 1, I can't use the servos anymore. All right, who needs a timer? We can do it without a timer. So let's remove the timer. Great. So inside of the loop, I will first remove this here. Let's remove this. Let's clean up a little bit. But 500 milliseconds is crazy. I will reduce this to 10 milliseconds for now. So right now we get a pretty good movement. And inside of this loop, I will now check if the record button is pressed. If digital read. So the record button is pin 9. And by the way, we need to define pin 9. Pin mode 9. Input pull up. And the same for pin 8. So if pin 9 equals 0, which means it is pressed. We can also write if not, I will add a comment, this is my recording. So as long as this is pressed, we record. Else, not recording. So if I'm recording, I will save the X into the array. So I will grab my arrays. I need this array, I need this array, and I need this array. So I will save X into this one, I will save Y into this one, and I will save the light into this one. So the current X goes into the first one, the current Y goes into the second one, and the current light goes into the third one. And which index are we going to use? Well, we need a new variable. We need a variable that starts at 0 and goes up. Let's call it current index. And current index will be a byte variable. And it starts at 0. Byte is enough because the maximum index that is allowed is 199. We can store numbers up to 255. And then after we store it inside, we need to increment the current index. But we only want to do this as long as it's below 200. If current index is smaller than 200, then increment it. The problem with that is that we would stay at the last index and then overwrite the last index, and then it would be a jump to the last value, which I don't want. So we put this if around everything here. So if it's below 200, we store values and we increase the value. If it's not recording, I will reset the current index to 0. Because every time we start recording, we'll start a new capture. Yeah, that should work. And I would say, let's do it like this. If recording is pressed, then we record. And else if the playback button is pressed, I would like to manipulate these values right here. In order to playback, we need to write the value to the servo, but not x, which is the current x. We would like to use this value right here, the value that is stored inside of the array. And we will do the same for y. And we will do something like this. Let's put this here and also add this stuff right here. If the light is 0, if this light right here is 0, then turn it on. And this right here is dangerous because it overrides my playback. I will do it like this. If it's not pressed, then playback. Yeah, this solution is a little ugly, but I will do it like this. Yeah, this thing also needs to be inside of this. I will also add a full memory. Let's see. Okay, it still works. Can turn on the light, that's good. If I push record, and now this should play back, and it doesn't play back. Why? Let's debug. Let's call it play. Println play. This should play back. Yeah, it should play. Should play. Problem is that we don't increase the index, because when we play back, we also need to increase the index. If current index is smaller than 200. Okay, let's try again. I will capture a movement and then I will replay the movement. Okay, that's amazing. And we could, in theory, also do something like this. Yeah. The code works, but it's very ugly, and we could now refactor it. And we should refactor it. But I would say that's a topic for another video, or maybe you can tell me in the comments down below how to refactor this code and make it nicer. I will also share this code on GitHub. So if this video was helpful, please like and subscribe to this channel if you're ready to dive deep into the world of Arduino. Thank you for watching. See you in the next lesson.